Last video, we were looking at trig ratios. And I apologize that 1.2 notes didn't line up very good on my printout here. The ones in class work out better. But the sine of an angle equals a ratio. So we're always getting the ratio of two sides. Well, the opposite of that, the inverse, x and y would switch. The inverse of the ratio gives me the angle. So this is called the inverse functions. They're also called arc sine, arc cosine, or arc tangent. In an arc calculator, it puts an A in front. So A sine, A cosine. So above sine, cosine, and tangent, you see these A sine, A cosine, A tangent. Those are the inverses. So if I wanted to find inverse sine of square root of 3 over 2, that's actually in my calculator going to be A sine, arc sine. So what I'm going to do is I'm going to press shift sine. See, it says arc sine. And I'm going to type in square root of 3, but I have to press the right arrow to get out of the square root of 3, divided by 2. And it tells me that the angle that gives me that ratio is 60 degrees. Cosine. So shift cosine, negative 1/2, is 120 degrees. Inverse tangent of 1 is 45 degrees. Now, this one I have to be kind of careful with because it's giving me cosecant and cotangent. Cosecant is the reciprocal of sine. So what I could do is do the inverse sine of the reciprocal. So I'm going to do inverse sine of 1 over the square root of 2. And it gave me 45 degrees. And this one, cotangent, is the reciprocal of tangent. So this would be the same as doing the inverse tangent of the reciprocal. So that would be negative 1 over the square root of 3. So negative 1 over square root of 3. And it says that's negative 30 degrees. Notice when I'm doing these, I can get negative and positive angles. And we'll be looking into what those really look like a little bit later. But I just wanted to practice putting those in the calculator. So what we're going to be doing today is using the inverse trig functions to find angles. So I'm trying to find the angle theta here. And so 50 is across from the right angle, that's the hypotenuse. 10 is across, that's opposite. Opposite hypotenuse, that's sine. So sine of theta equals opposite over hypotenuse. Now if I know the ratio and I'm trying to find the angle, I'm going to do the inverse sine. So I'm going to just do A sine. So you get used to that's what it's going to look like in the calculator. If I do the inverse of sine, which is A sine, arc sine, it's going to give me the angle for that ratio. And it gives me 11.537. On this one, the angle is x. This is opposite. This is adjacent. Opposite and adjacent is tangent. Opposite over adjacent. So if I know what the ratio is, to find the angle, I'm going to do the inverse tangent of the ratio gives me the angle. So inverse tangent gives me the angle. A 40-foot ladder leans on a house. The base of the ladder is 6 foot, so base would be here, 6 foot from the house. find the angle between the ladder and the house. Ladder, house, right here. So if that's where the angle is, 40 would be the hypotenuse, 6 would be opposite, opposite and hypotenuse would be sine. So sine of theta equals opposite over hypotenuse. So to find the angle, I'm going to do arc sine or inverse sine. So you can write it either way. And the inverse of the ratio gives me the angle. So arc sine of 6 over 40 gives me 8.627. A 96-foot tree. Tree is 96 feet. Casts a shadow. That's 120 feet long. And we're trying to find the angle of elevation of the sun. So that's from horizontal looking up, elevation to the sun. So I'm trying to find that angle. So this would be opposite. This would be adjacent. That's tangent. Opposite over adjacent. And you should get 38.66 degrees. A lighthouse is located on an island that is 2 miles off of a straight shoreline. So it says this is 2 miles. And the distance here, D, is 6. And they're trying to find this angle. So here's a right angle because it's a straight line. So this side would be opposite. This would be adjacent. So opposite, adjacent. We're looking at tangent. Opposite over adjacent. And I got that the angle would be 18.435. Now the last thing I want to show you is it's not really using the same thing. It's finding the area of any triangle. And so there's a neat little way we can do this. I've got a triangle here shown, and you'll notice that I marked where the height is. Well, that's because to find the area of a triangle, it's 1/2 the base times the height. So the base would be this entire length A, and the height is here. So in our case, this would be A times H. Well, a lot of times I'm not going to know what this H is. So what we're going to do is I'm going to use this angle and look at this as a right triangle. And I'm going to relate H and B. So H is opposite that angle. B would be the hypotenuse of this little right triangle. So sine of that angle would equal H over B. I'm going to solve for H. Now I want to show you something interesting. Since this is a representation of H, I can replace H here with that representation. We have a new formula for area. Now, the A and the B in this formula have to be on either side of the angle. So we have a new area formula, and this area formula is 1/2 a side times a side times the sine of the angle between. So if I know two sides and I know the angle between, I can find the area. So that would be 1/2 times 3 times 10 times sine of 120. And it gives me my area. Now, you could write these in exact or decimal. Just make sure if you're going decimal 3 places is what we want.